Hello everyone, Mr. Waz here, and welcome to this special episode of WasleyScience. Today, we are going to discuss
the most important words in science class.
Excuse me. Alright, well let's get started. So use this as a table of contents in case that you need to go directly to a particular word in this video. It's very possible that at a point in the year you're struggling with one or two of the words while writing a lab report. So feel free to click on any word that you are struggling with. Also, if you click on put it all together, you can get an explanation of how accuracy, precision, reliability, and validity all come together when writing your conclusion. So this section of the video should be really helpful for you. Alright, so let's start talking about the variables. You are probably really familiar with independent variable and dependent variable, but if you're not, that's okay. That's what this video is for. So the independent variable is the part of the experiment that you as a scientist change. I like to think of it as the cause. So this is the area in the investigation that you are altering, and you're trying to see what will happen when you change this one thing. It's the only part of the experiment that you actually change. The dependent variable is the part of the experiment that is expected to change. I like to think of it as the effect. So it's when you change this thing, what happens to that thing? And we will be discussing examples in the year. If you are having trouble identifying the independent and dependent variable, please see me, and I have some handouts that can help you with that. But the dependent variable is also the part that you measure. And that is really an important part there. Usually you are measuring time, you could be measuring temperature, you're measuring some sort of effect. And then there is the constant variable. You will, of course, have more than one constant variable. Hopefully you have multiple constant variables. This is the part of the experiment that you keep the same throughout the time of collecting data. And it's really important that you have multiple constant variables. The more constant variables that you have, the better your experiment is. So when we put all these pieces together, if you have an experiment that has only one independent variable and you measured the effect of when you changed that one independent variable and you kept everything else the same, we call that a controlled experiment. So a controlled experiment is just when you have one independent variable and you're measuring one thing and everything else is kept the same. If you have a situation that you are trying to change multiple things at once, your data is not going to be very reliable and you're not going to have a controlled experiment. So a controlled experiment is just a term that we use to describe the ideal lab situation. It's in other words, it's a good lab. A good lab is called a controlled experiment. So let's talk about how to make a hypothesis. A hypothesis is a possible answer to a scientific question. It's usually written in the if, then, and because fashion. What I mean by that is that you would write if the independent variable increases or decreases, then the dependent variable will increase or decrease or stay the same, because then you talk about something scientific that has to do with the independent and dependent variable. And when you write about your hypothesis in your conclusion, you only can support it or not support it with your data. And what I mean by that is some students will write, our experiment proved the hypothesis. You can't use the word proved. You can't use the word correct. You can't say our hypothesis was correct, because you can't really have a correct hypothesis. You can only have a correct theory, but you guys aren't going to be making theories in class. So, and the only thing you can prove is a scientific law, like, the law of gravity, Newton's laws. And we're not going to be doing that either. Most laws of our world have already been done. So in science class, we're only going to be making a hypothesis. And the only thing you could say about your hypothesis was the hypothesis was supported, or the hypothesis was not supported because of the data, and then you would talk about the data. So that's really important. I do take points off if you use the word correct, incorrect, prove, not prove. I only give credit to when you say support or not support. All right, so let's move on to the word repeatable. The word repeatable specifically refers to your procedure. We only use the word repeatable when we talk about our procedure. So instead of saying, hey, your procedure is really nice, or your procedure is really good, we like to say your procedure is repeatable. And what that means is that your procedure was so detailed and well written and easy to read and easy to understand that a totally random person, could walk into the classroom. Don't worry, I'll never let that happen. But somebody that's not familiar with your experiment could walk into the classroom, read your procedure, conduct your experiment, and then get the same results that you got. If you can write a procedure that well, then you would say that your procedure is in fact repeatable. And that's a goal that we're all going to have this year. And be ready to see if I do have somebody that comes into the class and reads your procedure and sees if they could get the same results as you. That may happen, so be ready for that. Okay, so now we're going to talk about consistency, and I have to say that consistency is the word that students struggle with the most because they have trouble deciphering the difference between a constant variable and something that is consistent. And you can see right here, consistency, the ability to do the experiment the same way each time. That sounds like that's exactly what constant variables are. But the thing that's different about consistency is a part of when you are conducting the experiment, and it's the parts that are directly related to you, the human, the person, the way that you are doing things. So, for example, if you have somebody that is playing a role in the experiment, they should be doing that role in the experiment the whole time in order to stay consistent. If there's somebody that's putting the rocks on the triple beam balance and finding the mass of each different rock, they should be the one doing each rock each time, because that's a consistency sort of way. If you have an experiment in which you are like dropping something into a cup, for example, you should be dropping the rock the same sort of way each time. You shouldn't be throwing it down. You should be just releasing it by your hand, and it should be, again, the same person that does it every time. So consistency is a part of the experiment that's really difficult to write as a constant variable that has to do with you directly. It's some sort of method that you're doing. So it has to do with techniques and methods that the person does with the experiment. And they're parts that you should include in your procedure, but they're really difficult to write, and they're parts that you can't necessarily and easily measure. Like, it's hard to kind of measure how you drop something into a cup. It's hard to measure how exactly you are finding the mass of a rock using a triple beam balance. So if you are struggling with that, it's understandable. It's a hard thing to understand at first, but listen to this section over again and it'll start to make sense to you. All right, so now we're going to talk about accuracy and precision. These two words have to do when you look at your data table and you're looking at the numbers themselves and seeing how good of quality they are. So accuracy is when you look at your numbers and you are trying to see how close they are to the true value. And a true value is a really tricky thing, because I don't think in any of your middle school experiments that you did, you were ever given a true value. A true value is simply numbers that are given to you, and they're the right answer. They're the numbers you should have got when you did your experiment. The problem with that is you wrote your procedure. So how could I or anyone generate answers to a procedure that you wrote? So you won't really get a true value. Other people could say that your true value is actually your average. Problem with that is you only did 3 trials most likely. So if you only did 3 trials, you can't really say that your average is the true value, because you would need to do anywhere from 100 to 1,000 trials in order for that average to finally become a true value. And then what you can do is you can look at your average and compare it to each trial and see how close it is to the average. And you can look at the ones that are really far away from your average and then say, well, that's not a really good trial because it's not close to the true value or the average. One example you can think of is that water boils at 212 degrees Fahrenheit. So if you boil water and you look at your thermometer, it should say 212 by the time the water boils, and that could measure how accurate your thermometer is. So let's now talk about precision, how to have precise data. Precision is really easy to do, and you could always do it in any of these experiments as long as you did multiple trials. Precision is when you look at each trial and you see how each number is close to one another. So if you look at all 3 trials and you have one number that's way off, then that wasn't a really precise trial, so you shouldn't include that. So an example is if you run a mile in 8 minutes, and if every mile that you run 8 minutes, then you're very precise in your running because you always run 8 minutes. If you ran 1 mile that was 8 minutes and then another mile that was 13 minutes, then you're not really precise in how fast that you run. Alright, so reliability is when the data is both accurate and precise. If the data is accurate but not precise, then you can't say that the data is reliable. You also should have multiple trials. You have to have multiple trials for your data to be reliable. Alright, so our last word that we're going to talk about today is validity. It's not validity. Some kids say that. It's validity. So validity has to do with your conclusion. You can or you cannot have a valid conclusion. And for you to have a valid conclusion, you need to have 4 things. The first thing you need to have is many constant variables. That's pretty easy to do in an experiment. The next thing is that you have to take into account how well the dependent variable was measured. So that's a really important part, and that has to do with that also has to do with accuracy and precision too. And then the third thing is how consistent you were with your trials, which, remember, consistency has to do with the things that you did with the experiment. So that has to do with methods and techniques. And last, you have to have multiple trials. And a lot of these experiments we think 3 is okay, which we usually go with 3 just because of time constraint. So that's validity. Alright, so now we're going to put it all together. So we're going to talk about 4 words in one sort of thing here. So we're going to talk about accuracy, precision, and then we're going to talk about reliability and validity. So a data table is a great way to understand all these words. So we have 4 rocks here, and the mass was taken of these rocks. Each mass of each rock, you took the mass 3 times for 3 trials and then calculated an average of that mass. And then there was also a true value that was provided. So this true value is the right answer. It's the actual mass of this rock. So for rock 1, there were 3 trials, 5, 2, and 12. The average came out to 6.33, and the true value was 9. So you can see here that they did a terrible job trying to find the mass of this rock. They were all over the place, 5, 2, then 12. So these 3 numbers right here are not the same numbers. So that shows that they were not precise. So now if we look at the average was 6.33 and their true value was 9. So that shows that they are also not accurate. So rock 1 is not accurate and not precise. Now let's move on to rock 2. So they have 5, 6, and 6. Those are really close. So this rock 2, they actually are precise. but are they accurate? So if you look at the average, 5.66 and then 10, they're not accurate. So rock 2 is precise and not accurate. Now let's look at rock 3, 10, 5, 7.5. So you can see here that they were not precise trial from trial. But when you take the average of the 3 and then you get 7.5, and if you compare it to the true value is actually 7.5. So this rock, with this rock, they were actually accurate but not precise. And then if we look at rock 4, 888, average 8, true value 8. So rock 4 is accurate and precise. So when you look at these 4 rocks here, you can see 4 examples. We usually call the person that gets this sort of data the space cadet. And then with rock 2, this sort of data, when you multiple times get the wrong answer, we call that person the consistent one, because at least they were continuously doing the wrong thing but the same way. And then we call the person that gets rock 3 the lucky one, because they somehow got the true value even though they were not doing the same thing each time. And then we call the people that get rock 4, well, that's a scientist, because that's where you want to be. Alright, so if the data table didn't help you out this well, reliable data leads to a valid conclusion. To be reliable, an experiment must be consistent, so that's the techniques you use, repeatable, so that's your procedure, and then accurate and precise. So you can see on the first dartboard that they threw one dart and they threw it and got bullseye. So by getting bullseye with one dart, that's like one trial, you could be considered accurate but not precise. If you throw 3 darts and you hit 2 every single time, you're not very accurate because you were going for bullseye, but you were precise because you hit 2 every time. And if you hit bullseye 3 times in a row, guess what? You're accurate and you're precise, which makes you a reliable dart thrower. Credits for organizing the dartboard example goes to John Schwartz. Alright guys, that's all I have for you today. Please click on the bottom to subscribe to my YouTube channel. What I have for you today is the what an awesome scientist does. So an awesome scientist creates a repeatable procedure, produces precise data, which has numbers that are the same, gets accurate data by having multiple trials and becoming close to the true value, stays consistent in their experiment with their methods and techniques, and then will create data that is reliable and then can draw a valid conclusion. So that's what an awesome scientist does, and that's what I hope you can do. So thanks a lot, guys. Take care.